So in this video, we'll go through the proof that our angle duplication method actually does work. So here's the setup. Suppose that we have an angle, and that angle is given by the ray AB as a side and the ray AC as a side. Now we wish to duplicate that angle and construct another angle that's congruent to that angle with a vertex at D, and suppose that we're given one side with the ray DE. Now what we want to do is to go through the method of duplicating the angle, and as we're duplicating it, showing you the method that will actually show you the proof that it really does work as well. And so the first thing that we will do is to draw a circle, any circle that has a center at A. And so we don't really care what the radius is, we'll just draw that circle. We'll call that circle C. Now that circle is going to intersect ray AB at point F, and C is also going to intersect ray AC at point G. Now what we want to do is to duplicate circle C at the point D, so that the D is the center of the circle. And so if we do that, we construct a circle little d, and the radius of little d is congruent to the radius of circle C. So D is going to intersect our ray DE at the point H. Now this means that our segment AF is going to be congruent to our segment DH. So what we're going to look at now is the segment here at FG. Now I want to construct a circle with a center H, and I want the radius of my new circle to be congruent to the segment FG. And so if I do that, let's call that circle E. Now what happens, E will intersect D at two possible points. So if we choose one of those points, it doesn't really matter which one, but if we choose one of those points and call it I, then that's going to give us another ray, DI. Now because of the way that we drew our circle E, we know that the line segment IH, so the line segment IH is going to be congruent to the line segment FG. And so what we have is that the segment AG is congruent to the segment DI. We have that the segment AF is congruent to the segment DH, and so we have the segment FG is also congruent to the segment IH. And so what we have in those triangles, we have a correspondence between the congruent sides, and so that means by the side-side-side congruence theorem that triangle AGF is going to be congruent to triangle DIH. Now in particular, what that means is that the angle AFG is then also going to be congruent to the angle HDI, thereby proving what we wish to prove.